Now let us come back to Ansys Workbench and open Ansys preprocessor. Double click this setup option. Now the mesh is imported into Ansys CFX. Now we shall specify the domains and boundary conditions. Since it is not a conventional turbo application, we cannot use turbo mode for this. We have to specify the domains in manual mode. So let us right click flow analysis and insert domain. The first one is rotor domain. We have to choose the inner domain and choose the material as air ideal gas. Let the reference pressure be 0 atmosphere. Click OK. Now the other domain by default will be showing as default domain. We can rename this as outer domain. By default it has identified the interface between the two domains. It is showing as default fluid interface. We shall rename it to fluid interface and first specify the interface boundary condition. So as per the domain filter, the first side is having outer domain, the next side is having the rotor domain. In the region list, we shall click these three dots and then choose. For the outer domain, it will be outer interface. Click OK. And for the rotor domain, it will be inner interface. Click OK. And the interface option will be having general connection. And for the frame change model, we have to choose frozen rotor, as it is having a frame change from rotating to stationary domain. And the rotation axis is global y-axis. Click OK. Now let us specify the RPM for the rotor domain as well as the boundary conditions. So in the rotor domain, we shall specify the RPM. In the domain motion, you have to choose rotating and specify the RPM. The RPM is 35.8 revolutions per minute and the axis of rotation is y-axis. Now click apply. Now please note, this is an important point. Here we have specified as 35.8 RPM, which is in the positive direction. CFX always uses right hand thumb rule for direction of rotation. Let me quickly explain about the rotation direction followed in CFX. For example, if the axis is x-axis, the rotation always happens from y to z. We can see here. Similarly, if the axis is z-axis, the rotation always happens from x to y. So here a table is given. Based on the axis, the rotation will be from the other two axes. Example, if the axis is x-axis, the rotation happens from y to z. Similarly for other two. Another method to remember this is rotation will always be in counterclockwise direction when viewed from the positive axis direction. For example, if you are seeing from the positive x-axis, the rotation will be counterclockwise. Similarly here, when you are seeing from the positive z-axis, the rotation will be counterclockwise. Let us go back to CFX. So when we see the turbine rotor, the axis is y-axis. So the rotation always happens from z to x. So here the rotation will be in clockwise direction seeing from the front, but in actual case the rotation will be in counterclockwise directions. So we shall change the direction of rotation in this section by multiplying with -1. Now let us specify the angular velocity as -35.8. Now it will be spinning in the right direction. Okay, now let us specify the other regions of the rotor domain. First let us finish the regions for the outer domain. Right click outer domain and then insert a boundary. Specify as inlet. Let the location be inlet and the boundary type be inlet. This is the boundary type and this is the location which we have created the names in Ansys Workbench. Coming to boundary details, let the normal speed be 15 meters per second as per our given rated speed condition. Click OK. Before starting, let us specify the fluid models here. It is not isothermal condition, we have to specify as total energy. Click OK. So come back to the outer domain inlet. Specify the temperature as 15 degrees Celsius. Click OK. Right click outer domain, insert boundary, go to the outlet region. By default it has chosen the outlet based on the naming. Now in the outlet we shall specify 1 atmosphere pressure. Click OK. We shall specify wall condition for the other four faces. By default it has chosen wall. Click OK. In the rotor, let us specify wall condition for the rotating turbine blades. By default it has taken turbine. Click OK. Now all the boundary conditions are set up here. We shall modify the solver control and click OK. Next we have to specify the expressions for mass in, mass out and torque value. Based on torque we can calculate the net power generated by this turbine. Power is given by torque into omega, where omega is the angular velocity of rotating blades. Right click expression and create mass in. Right click functions locator based mass flow, add physical locators 2D inlet, apply. Similarly mass out functions locator based mass flow at physical locators 2D outlet star -1. We shall multiply by -1 since it is going out of the domain. Now create an expression for torque. Click torque functions locator based torque at physical locators 2D turbine. Here this expression will give you the torque output on the blade, on the turbine blades. Click apply. Now go to output control, click monitor objects and select the parameters. Click OK. Now the case is set up. We shall close preprocessor and start the solver. Open CFX solver. And run the case in parallel mode. Now solver has started. We shall check the converged solution and post-process the results in the next lecture.